sklearn experimental, a deep dive into scikit-learn's experimental features. What is sklearn experimental? The sklearn experimental module in scikit-learn acts as a sandbox for experimental features that are still under development. These features might not be stable, fully documented, or have undergone rigorous testing. Using these features involves a higher risk of instability and potential breaking changes. However, they offer a glimpse into the future of scikit-learn and allow early access to cutting-edge developments. Why use sklearn experimental? Early access explore new features before they become officially released in the main scikit-learn library. Testing and feedback provide feedback and contribute to the development of new functionalities. Innovation experiment with new algorithms and techniques that are not yet integrated into the core library. Important considerations. Stability features in sklearn experimental are not guaranteed to be stable. They might undergo changes or be removed entirely in future versions. Documentation for experimental features may be limited or incomplete. Deprecation experimental features might be deprecated in favor of more stable alternatives in later releases. Support expect limited official support for issues related to experimental features. Key features in sklearn experimental. 1. Feature selection. sklearn experimental enables iterative imputation using KNN for missing values. 2. Data preprocessing. sklearn experimental enable hist gradient boosting allows for gradient boosting with a histogram-based algorithm for faster training. 3. Model selection. sklearn experimental enable halving search CV implements a halving search strategy for efficient hyperparameter tuning. 4. Clustering. sklearn experimental enable cluster perturbation introduces methods for perturbing clustering results to assess their stability. 5. Ensemble methods. sklearn experimental enable hist gradient boosting enables gradient boosting with a histogram-based algorithm for faster training. 6. Others. sklearn experimental enable iterative imputer allows using KNN for missing value imputation. sklearn experimental enable hist gradient boosting enhances gradient boosting with a histogram-based algorithm for speed improvement. How to use sklearn experimental. 1. Import the module. Python. From sklearn experimental import enable halving search CV. From sklearn model selection import halving grid search CV. 2. Use the feature. Python. Halving search halving grid search CV. Use the enabled feature. Example. Python. From sklearn experimental import enable halving search CV. From sklearn model selection import halving grid search CV. From sklearn datasets import load iris. From sklearn linear model import logistic regression. From sklearn model selection import train test split. Load the dataset. Iris load iris. X iris data. Y iris target. Split the data. X train. X test. Y train. Y test train test split X. Y. Test size 0.2. Random state 42. Define the hyperparameter grid. Param C 0.1. 1. 10. Penalty L1. L2. Create the halving search object. Halving search halving grid search CV logistic regression. Param grid CV5. Factor 2. Resource n samples. Random state 42. Train the model. Halving search. Fit X train. Y train. Print the best hyperparameters. Print best hyperparameters. Having search, best params. Important note before using experimental features. It's strongly recommended to consult the official documentation and release notes for the specific version of scikit-learn you are using. This will help you understand the limitations, potential risks, and any known issues related to the experimental feature you intend to use. By using sklearn experimental, you can explore the cutting-edge developments in machine learning and contribute to shaping the future of scikit-learn. However, always proceed with caution. Be aware of the potential risks and use these features in a controlled environment.